Hello, online students, can you hear me? Yes? Okay. So, we will start. Today we will talk about a new topic. It will be about what we call face biometrics. Okay? So this is the purpose of our presentation. This is the outline. And I would like to explain to you, just maybe we turn on the projector, yeah. Sorry, no, the other one. Few seconds, just we turn on the video projector for the on-campus students. Il faut le laisser tout le temps en permanence branché. C'est par la tête. Parce qu'en fait, si on le débranche, là ça. Okay, good. So what I said, this is the objective, is to talk about face biometrics. So just to try to have a look on the outline. So first of all, we would like to introduce face biometrics in general. Okay, we'll be talking about some generalities. Why we are interested in face biometrics. And we will be talking basically about recognition, okay, face recognition, age estimation, gender estimation, expression estimation, and so on, okay? And we will give you some examples. And so look at just this first module. This one is just some generalities, but after this we'll be talking about some details on face recognition. So we'll be talking about especially some different modalities, especially in 2D, 3D, some global approaches, some local approaches, fusion methods, and so on. Okay, and the last one will be about a specific algorithm used in face recognition called the PCA. PCA means Principal Component Analysis. Okay, Principal Component Analysis. So we try to do it progressively, you know. And what you have to understand for you as a student, one, you have to understand why face biometrics. Where can we use face biometrics? And how can we implement a face biometrics system? And maybe at the end we can talk about evaluation of face analysis biometrics. Okay, so very often, you know, when we talk about face analysis, it's not very interesting to start directly by algorithms. What I mean about this, it means I give you one face and I tell you, okay, who is this person? Can your computer recognize the person? And you run an algorithm, and at the end you said, yeah, this is this person. We are talking about identification. But as I said, it's not interesting just from the beginning to start just running algorithms. So for this purpose, what you have to understand, why we deal with face biometrics. In which applications? If you are convinced about applications, after this you can start programming, developing some systems, some algorithms, and so on. So it will be in this session, you know, I will give you some general ideas about face recognition, but at the end of this semester, normally you should be able to implement your face recognition system. When I say you should be able to implement, it means you should be able to create your application. Okay? And because this is the purpose. As an engineer, people, they would say, okay, can you implement, can you create, can you develop a system based on face analysis? So you have generalities, you have sometimes you can take have an idea about some algorithms, and after this you will have an idea about how to implement face analysis. And here you will meet many tools. Okay, for the moment we start from here. Okay, and when you arrive at this level, you will learn how to implement face analysis or face recognition system using a specific platform called Laxand. Okay, so it's a kind of SDK. Do you know what SDK? What does it mean, SDK? What is an SDK? When we say we will use an SDK of Laxand, software development kit. In fact, it's a set of libraries. Okay, when we talk about SDKs, set of libraries that you can integrate in your environment, in your C++ environment or something like this. So you develop an application and you say, okay, now I can integrate some libraries coming from some SDKs. Okay, and you will take a lab about this, how to use SDK face recognition from Laxand. So it will be about integration. You will learn about also another platform called Face++. Have you heard about this? Face++. So there will be some labs on this, and in fact it's just another library with different APIs. You know, when I say APIs, okay, and codes that you can integrate in your environment so that you will be able to create your own application. Okay, but before starting with this kind of SDKs, okay, this is SDKs and or Face++. Of course, you have to start with something simple, is to program some routines in MATLAB, at least to understand how things work, and after this you can develop your own applications. Okay, so in terms of applications or implementation, so you have MATLAB, okay, you have Laxand and Face++. So one or two labs in Laxand, one or few labs with Face++, but at the beginning you have to start with MATLAB. So this is, I'm talking about the integration and implementation. But before doing this, it's very important to understand the purpose, you know, the purpose of face analysis. So let's see the slides, and let's start with the first part. Okay. Okay. Good. So when we talk in general about face analysis, it's basically to use it or to use face features in different applications. For example, you can be interested in age estimation and age modeling. So can you say something about this? Why sometimes we need that our computer estimate the age of a person? Age estimation using face analysis. Why in some cases we need to make our computer able to estimate ages? Can you imagine some application?
Yeah, the application about when someone gives adult or kid who can be enrolled or not to enter, for example, the website.
Yeah. You know, when, for example, you have one adult and you have one kid, for human being it's very easy. You need to estimate the age of the person, and you say, hey, you seem to be under 12, so you cannot use this software, you cannot access to this place, and so on. Okay, the human being, it's easy for him to estimate the age because we are using this very often. We see someone and say, ah, this guy looks like he's 24, looks like he's 10 years old or something like this. And based on this information, you can take a decision. That's why if you estimate the age of the person, you can take a decision, because we are doing this every day. Every day we are doing this processing. Even we don't ask ourselves, just we do it naturally. Okay? Each time you want to do something, you discuss with someone, you say, okay, yeah, probably this guy is 60 years old, 50, 40, and you can take decisions based on the age estimation. Okay? But here, what we want to do, we want to make the computer estimating the age at our place, just to make things automatic. You know, if you want to access some specific website, and we say this website is just for kids, okay? We want to discard all adults. So here, if we estimate the age of the person, we can allow only kids to access to some website, or maybe to see some special channels just for kids or something like this. So we have a lot of applications, and we can talk about this even later. Gender estimation. The same thing between humans. You know, one person when she or he looks to another person, directly can say if it's a man or woman. Okay, it's something natural. But making this, you know, teaching a computer to make the difference between a man and a woman, it's something else. Our brain has a way to analyze data, but a computer should be trained. You have to train your computer to make a difference between man and woman. Expression and emotion. In some cases, especially in some smart devices, we would like that our computer can take a decision to say, oh, okay, in front of me I see someone who is sad, I see someone happy, I see someone crying or something like this. The same, for human it's something easy, but for computers it's something very difficult, and you have to train your computer so that you can make difference about expression, because we have a lot of applications where we need to estimate or to define expression of people so that you can make an interaction between a human and a computer. It's like in gaming, okay? In gaming, or we can imagine in the future some smart mirrors, you know, when you see yourself and the mirror can detect your expression, your emotion, and based on the expression and the emotion, we can make the smart system interacting and maybe even helping the person, okay? So you can imagine lots of applications. And of course, we can talk about recognition, especially for identification or verification. So here it's much more related to security. Other applications, some of them can be applied in security, some of them can be applied for some smart systems. When I say smart systems, especially now we think to develop some new systems that interact with human easily. So it's important, if you use a camera, you capture a face, and when you have the image, you have to extract features, and based on these features, you have to decide to see if the person is, I don't know, if you are interested in expression or emotion, or you want to estimate the gender. So you can do it, but using another language. It's not human language. You have to develop some algorithms, and this is the challenge: how to teach or to train a computer to think like a human being. This is the challenging part. Okay. So if I show you a face like this, and I ask you a question, how can you guess the age of this person as human? What can you say? Someone says 31, okay, 25, 40, 32, what else?
30 and 35.
Pardon?
Between 30 and
34. Okay, so we will see. So for us as human being, you know, we are different persons, and each person estimates the age. And for the moment, we got this estimation from humans. Okay, but certainly this person has real age, okay, which is 24. Okay, she's 24, and look at your estimation. So can we say this one is better, or this one, or this one, or this one? Who is right? You can tell me, yeah, maybe probably this one is closer. Okay, so maybe it was just who said 25? I'm just looking for. Okay. Okay. So if just one person says 25, maybe it was just by chance like this, 25. Because if I ask the person to estimate the age of another person, maybe the error will be much more important. But what you have to understand, in science, very often estimations or the analysis should be based on statistical analysis. Okay, so as human, of course, we can estimate the age, and from all these values, we can make some statistical analysis. What does it mean when we say statistical analysis? Even, yeah, we can ask many persons, okay, to do exactly the same exercise. And after this, what we can do, you can tell me, you can average all these values, and you will have the mean. So maybe if we average all these values, maybe we will find something around the 28 or something like this. But the in statistical analysis, you know, the mean is not very representative, so you can add some other information like, tell me, standard deviation. Okay, you can add standard deviation, and in statistics, sometimes we can even use what we call HOS. It means high orders statistics. It means we don't stop just at the level of mean and standard deviation, but we use other parameters to characterize something statistical. But very often, you know, we stop just at these two levels, you know, the mean and standard deviation. Sometimes it's enough. So here, as human being, you can do this. You can make a kind of a statistical analysis about your estimation. But our purpose is to make a computer thinking like human. So using the computer, you can just capture the face. Okay? You detect the face, and from this face, what can we do? If now we think as a computer, we extract some features. When we say features, alpha 1, alpha 2, alpha 3, and so on. And based on these features, we can make a decision. We can estimate the age. So remember what I told you last time about the block diagram. Always we can use exactly the same block diagram as I will share. Okay, so this is the. Okay, remember our main block diagram. This one is for to capture data. This one is for, tell me. You don't have to forget this block diagram. It should be, you know, no, you see, that's capture, pre-processing, feature extraction, and after this, you see, right now, it's not memorized as it should. And after this, decision and output. So, if here the input will be in face analysis, it will be one face image. Okay? We pre-process the data. It means we remove anything which is not useful, and we keep only what is interesting for us. For example, you detect the face, because why? You don't need to work with the hair, you don't need to use ears, you don't need to use the neck, or I don't know, all the background. It's not interesting for you, and you say, okay, let's pre-process the image, and I have to use, I need to detect the face. So, okay, and maybe we can change the color or make it, you know, just when we say pre-processing, it means you are preparing the image before the phase of feature extraction. And here, once you have your region of interest, you will extract some features, okay, and you will get your signature. It will be stored in a database. Just remind me, what is our application? Age estimation. So the input is one face and the output should be the age. If you understand this, after this you will be able to to develop your system. And you can notice each time I'm using the same block diagram. The only difference is that maybe the input will change, the output will change, and the way I play with all these different blocks. Okay? So, in fact, remember in the block diagram, very often we use, in fact, two modules. We use the first one, it's like for training, to train our system, train the system. And after this, we can use it to test it, to use it. Okay? Here, it's like you are teaching, you are, okay? Or the system is learning. And here, the system now is ready to use, and you can use your system. So, what's the difference between training and the test phase? Tell me, if I consider this application of age estimation, and you can notice it's exactly the same block diagram as we are used to work with. So for the training phase, we have to train our system to say, look, I will show you this face, and this person is 16 years old. Okay? I show to the person one face, and I say this person is 16 years old, so extract features from the face, and in my database, how it should be organized. Tell me, for this application, how it should be the table. Here, what should I what will be the information I have to store here? Age, yes. Why you suggest age, but slowly? You are not sure of yourself. The age, because this is what we are looking for. This is what we want to estimate, the age. So here in the training, you are training your system. So for sure you know the age of the person, right? You know the age of the person, and you say she's or he's 16, but you need to process the data, and you say, okay, for this person 16, this is the signature it should be stored in front 16. And after this, I can do the same thing with 32, 31, and so on. And each time, I will construct my database. Do you agree? Yes? So your table here, based on this application, you see it's the same design, but what I will play just with the parameters. This is an application of age estimation. Okay, no problem. In my table here, I will have just ages. And here in front, I will have all the signatures. So at the beginning, you train your system. It's like we say, we enroll persons. Okay? You are teaching. You are teaching to a computer, okay, what is an age. And you tell him, I will show you this face, and the main information of this face is the age, and I would give you a value. It's 16. Now try to extract features. Next time if you meet some features close to this ones, you can think maybe that the person is 16. Okay? Because you have to understand the computer at the beginning, you know, when you use it the first time, computer is not smart. In your memory there's absolutely nothing. It's up to you to tell him how he should think. Okay? And you tell him, okay, I show you this face and I give you information. This face or this person is 16 years old. Now extract features and store them and try to associate or assign to the age 16 a signature. And do it for 32 years old, 32, 40, 15, and so on. Okay? And now, if you take the test phase, what will be the test phase?
When we test the application, we don't tell the age of the person, and the system tries to...
We don't know the input value. For example, take any face from we don't run.
Here, if we want to test our image, just as an input, it will be one face image, and we let our system estimating the age. Right? So at the beginning, it was a training. And after this, it was a test. So it's like you as students. You take classes and we give you inputs. Okay, you are learning things, and after this there will be a kind of exam or project, and after this it's up to you, you know, to create something. So in the training phase, just you act like just a system. You will just take inputs, you organize your ideas, you do some trainings, that's all. But in the real life, it's different. We suppose that you are already trained enough, so you can take a decision alone. So it's exactly the same. Your system, you train it at the beginning. You will show to the system what is an age, how you can characterize an age, and so on. And after this, the system will be smart because he will face some situations. He says, okay, this is not the first time I do this. I know how to process the data. So that's why always, and each time I present this block diagram, and you don't have to forget it. If you forget this block diagrams like this, believe me, it will be difficult for you to develop applications. It will be difficult for you to understand the purpose of any application. So look here, the application is age estimation. Now if I replace it by gender application. So tell me how I will change the block diagram. I will just delete, select all, delete. Okay, so now the application is different. Gender application. sorry. So if I say, okay, normally it will be the same block diagram. This is the first thing. Without thinking, you know, my database. And here, one block for the decision. And I will do the same, you know. Here I say a kind of training, okay? And here I would say I will test my system. So the input, I will connect all these blocks. And I am waiting for an output. The input will be
is to capture a
face photo. Okay. Next, we pre-process. You keep in it, when we say pre-process, you keep any region of interest. If you are interested in some specific regions, so it's up to you. Okay, so you keep one region or many regions of interest. You do the same thing, you extract features, and you will construct your database. And now, how it will be constructed? Tell me. Here it will be gender, male, and here you will have female. And here I will store one signature, and here it will be one signature. All right? And the decision here, the output will be male or female. So at the beginning, I start my training. So how can you imagine the training? How can you train your system?
You have a set of females and set of
Yeah.
male.
So you can create a set, you know, you have here males, okay, and here a group of females, and you will do exactly the same process, okay, and you extract features from the first one, second one, third one, and so on. And after this, you can keep them, or maybe you can just merge them or use some fusion to extract some main signature. And you say, this signature I extracted from statistical analysis. It's not extracted from one person, from many persons. It's like you observe many persons, man, female, and so on. So here it's a training. It's like you take a robot, the first time in his memory, he cannot make a difference between a male and female, and you say, okay, to the robot, I will teach you, you will learn what is a man, what is a female, just from the face, because this is what we try to do, to analyze just from the face. And you will show him one face, and you say, this is male. Okay, and you extract features, and he will store the information, and you do the second time, third time, and so on. So we call this training. You are training your system, you are training your computer to show him how to make a difference between male and female. And once your system is trained, you can use it. You are in the test phase. In the test phase, it means just I give to my computer one photo, and he should estimate the age. So you notice something. When I change the application, I didn't change anything here, right? The only thing what I change is basically the way I construct my database. That's why for you it should be easy and directly, once we give you an application, directly you have to imagine this scenario. You have to imagine this scenario because it will help you, it will be helpful. Whatever, regardless if you are in the field of electronics, computer science, or I don't know, a scheme like this will help you. Will help you not just to develop your application, but also to discuss with other people in the same team. If you are a team and you are working in application, when you have a scheme like this, at least you can easily discuss with people. Say, okay, you can work in this database and we want a database like this. You can work in just classification methods for the decision. You can work on this and so on. I gave to you 2 or 3 examples. Now, if I change the application, and the application will be expression estimation, or expression and emotion estimation, and I ask you a question: what will be the scheme for this application? So, is there someone, can I call one student here to design the scheme? Who can hear? One student. My objective is to develop expression and emotion estimation. So try to do something like this. What I did here, just try to do it here for this application. Who wants to do it? I don't know if online, who can do it online? We can try, maybe. Who can do it? Someone maybe online, and we can, yeah, we can give him the control. Who wants to do it from online students? I'm waiting. You? Okay, good. So, let's, okay. Yeah, I will give you the control, and you can, in fact, normally you can, yeah. Normally you can use the whiteboard. Try to do it. Normally you can write on the whiteboard. There are many people who said yes, 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 but I need, yeah, there is someone who is drawing. Good. Who is doing this? Watara, right? Rawal, yes, I cannot give control to many students at the same time. It will be very difficult because we will get not real scheme, but there will be a kind of Picasso in the whiteboard. So that's why, yeah, next time it will be you. Okay. Okay. What are yeah. Okay. Good. I want to help you. Just tell me what will be the input here. Okay, face. Okay, I will try to help you. I need basically here in the database how you will construct your database. This is the most important thing. We let maybe Watara, can you say something, or what should I store here? Because this is the most important. If you understand how you construct your system, after this it will be easy to develop it. Okay, and we are talking about age estimation, because when you talk to someone, can you develop an expression, an emotion estimation application? Maybe for someone this is, oh, it's very difficult. I cannot imagine how my system will work. But if you have a system like this, okay, someone says, Watara says crying. So here, yeah, here, someone who is crying, okay, so you understand. Here it will be sad. Here it will be smiling, and so on. Okay, so the input will be a face, right? And don't forget, we have this training phase, right? So now I know exactly how to construct my database, right? And this one should be connected to what? To a decision module. Okay, so as input, just tell me, I will provide, of course, a face, but at the same time, I need to give another information. The expression, because you say, okay, I will give you this face, but at the same time, this person is smiling, so I will extract features from the face, smiling, and I will store the information here, smile. Okay? And you will get signature here. You can do the same thing. For example, another one is smiling, so you can use a kind of statistical analysis. Okay? If, for example, you can, in this training phase, you take 10 persons, all of them are smiling, and each time you extract features, once you extract features, you will get a signature. You can calculate maybe the average, you can decide to do anything, you know, and you say this is the signature of a smile, and you store it here if you want to do something statistical. Okay, let me just maybe, I want to, oops, I want to remove this part, delete it, okay, good. So, as input here, each time you provide the face and the mood or the expression, smile, cry, sad, and so on. And each time you store the information here. Okay, so this is the training phase. Now, what will be the test phase?
Give a test, get expression.
So, in the test, once you finish with the training phase, your camera will capture a face of anyone, and it's supposed to say if this person is smiling, crying, or sad, or anything. So the output here should be the expression. Okay? Smile, sad, and so on. So you can understand that the output here, in fact, we find all these entries here. Is it clear? So you can notice if I work on estimation, gender estimation, face recognition, anything, I need to use a scheme like this. I need to use a scheme like this. And just I have to understand what should I use here as inputs, what should I provide as input in the training phase, how should I construct my database, and what will be the output. The output is, the user, the final user, will pay attention to the output, because if you want to explain to someone the purpose of your application, you say, my application is capable to estimate the expression of someone. Okay? So normally, in the future, if you can just imagine one application, I can give you an exercise one day like this. One application, and I tell you, okay, just to give me the block diagram, and what you can do, you have just to fill, okay? You have to design. So it's up to you to say, I give you just an application and you have to explain what you should use as an input. I need maybe feature extraction like this. And you have to explain what I can store here. You can explain what will be the output. You can explain what to store as information here. Okay, you can explain how the training phase works and how the test phase works. So in fact, just imagine your application. Before starting doing anything, imagine your application. You project it over a scheme like this, and after this you start really working. So this is the first scheme. It means you say, now I understood what I had to do. Don't forget, you are computer engineer, project manager. Ideas should be clear. When you discuss with a customer, for example, you have in front of you a customer, and the customer comes with his ideas like this. We want to develop an application to do this, 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 this. Okay? He will use his own words as a user. He says, I need to, like, when I push this button, when I do this, as an output, I should have this information. So the customer technical guy. Once you have this information, you can try to project this information over a scheme which looks like this. And based on a scheme like this, you can start discussing with him about data capture, and you say, okay, for your application, can we can propose that you use a camera. Maybe the other one says, no, we cannot use the camera because in our company it's forbidden and we should have some approvals and blah blah blah, and there are some laws, something like that. You say, okay, now I can propose to you to use another type of, to capture the data, maybe voice or something like this, or signature. And you say, yeah, okay, why not? Or maybe he says, yes, it's interesting, but I need to have an idea about the cost because maybe this modality is too expensive for us, and so on. So, when you have a scheme like this, it will help you to discuss with the other person, but at the same time, it will help you to develop your application. It will help you to know who can be involved in this project. Okay? It's not difficult, but it's about a way you organize your data. Before even talking about algorithms or different methods or the equipment or the materials that you want to use. Okay? So normally, if we give you any application, you should be able to fill the missing information here. And if you can do it, it's just a starting point. Okay? Do you have questions? So if in any control exam, if I give you something like this, it will be easy. I hope so. So just I invent any application to say, okay, I need an application like this. Explain to me how you will manage it and what are the different blocks and what will be the scheme, and you can explain different parts. Do you think that you will be able to do it? Do you think that it will be easy to do it?
I will ask you to say how the signature works, like explain signature or
after this, it depends at which level. I ask you, we can ask questions at many levels. So this is the first level. I give you an application and you have to design the scheme of your application. This is the first level. And after this, of course, we can ask questions here. How do you can pre-process your data? Or maybe questions here. What can you propose as feature extraction method? Which algorithm you can use? And why? So you can propose some algorithms. But we can discuss about it, because I say, okay, why this algorithm? How about the complexity? Because two engineers can propose different ideas, different methods of feature extraction. So I can give the same application to many persons, and I'm sure that they will develop different, functionalities, different algorithms, and so on. So if I give this project to two different persons, how to make sure which one is the best? Evaluation. Some evaluation methods. Evaluation methods in terms of results. Very often, we evaluate something in terms of results. But if you are a project manager, you can evaluate different things. You know, things different. Yeah, the cost and as I said, the time to market and things like that. So there are many ways to evaluate your work. So I think if you understand this idea, and each time I try to use the same scheme, and I don't know if it's now it's memorized or not, because what I want you, it's not just to memorize a scheme like this, but at the same time to be able to project any application over this scheme. This is the most important thing, is to say, now I feel that I'm ready, whatever is the application, in the medical field, in the any application, is to, of computer vision, of course, is to be able to project it over a scheme like this. If you feel that really you can do it, I think it will be really helpful, because after this you will work on the details. When I say details, yeah, different tools, different algorithms, you can start to choose, you know. It's like someone who wants to construct a house. Okay? You want to construct a house. Of course, you need some information. You need to say, yeah, I need my house should be. We can imagine a house, a simple house like this. Do you remember when you were 2 years old? You used a house like this with just 2 windows and 1 door. Okay, and you can imagine another house, I don't know, much more sophisticated, you know, with the garage here, with the, I don't know, entry here, some big and so on. This is the first floor. Now, you know, there is something about this is important, and after this, once you have your house, you can start, you say, okay, now I will go to room number 1 and I start to design it, and I go to room number 2 and I start designing, and so on. So if things are beautiful inside, okay, inside it's beautiful because you have a nice TV, nice sofa, nice anything, nice kitchen, but outside it's not something robust. It's something that you did just quickly. It's not nice. It's not sometimes not compliant. It's very important. Not compliant to some rules. So people, they will not be interested in your work. That's why when you have the general scheme, you have all the, you know that your house will be like this. Okay, and this is the main entry. This is, you have a room here, you have kitchen here, you have something like this here, I don't know, and so on. This is a general idea, and after this you can design in each room. Why? Because at least if you discuss with your customer, he's okay about the general design, and they say, yeah, it works. But if when you design something and you forget to add doors, and you forget here you have 2 rooms and we have no windows, so it's like we don't know what are the inputs and the outputs. Okay? Input and output is very important. So it's exactly the same. Having a scheme like this, this is general, okay, general scheme, and after this the details are here. The input is very important, the output is very important, information stored here of course are important, signatures are here. Okay, so training, test. What else? And after this, details here, details here, details here, and you need details here. And it's finished. Right? Is it clear? Good. So just let's play a little bit just with quickly with these persons. How old? 67, 60, 70. How much? Who said? Really, I don't agree with. Are you crazy? 69. Okay, let's see the real age. 70. Hopefully, because if it was 53, we will look ridiculous, you know, because there's some. Yeah. Okay, good. Okay, so here human estimated, this is the real age. These are estimations from real persons, and we can imagine a computer who wants to make an estimation. Okay, here 70, if I do a statistical analysis of this one, if I calculate the age, maybe I will find, I don't know, 67. Okay. This is, this is real. This is the estimated by humans. And your computer can estimate, of course, maybe something like this. So you have 3 values. And here it's like a competition between human and computer. The computer estimates something and human estimates something. So what is the purpose? Should we should be close to this one or to this one? What is best situation? To be close to 67 or to be close to real age? Real age, or we have 3 values: 67, 70, and 64. This one is the computer, estimated by computer. This one is estimated by human. And this one is the real. What is the most important? No, my question, my computer, it just tries to copy the human being, but the human being has one objective, is to estimate the real age. And the computer has also the same objective, is to estimate the real age. The computer tries to copy the way people they think, but maybe the computer can use other methods, some physical information, something different, some different measurements. So this is the idea, because here with the computer you are not limited. Okay? Why? Because look, the let's select all. Human being will use, look, a human being will use maybe just a general appearance of this face. He will use his brain, his background, and he will estimate the age. But your computer can use many things. You can use the face. What can you use too? You can decide to use other sensors, for example. We can use infrared. We can use, you know, something else, some sensors to capture some data from this face, and the computer will estimate the age. What you have to understand here is like a competition between human and computer. If we can do the same as a human, it's good, but if we can do better, I think it's very good. You understand? Computers tries to copy humans. If they can do the same as human, it's good. If they can do something better, it's very good. Okay? This is the purpose. Another one, quickly. 896. What else? 5. Okay. What will be 3? Who said 9? I'm Rawal. Okay. Who was close to? No. No, it was for the. Okay. So here, and if we calculate the mean, maybe we will find something like 7.5, something like this. But if we give this information to the computer, maybe it depends on the way the computer will process the data. Maybe you can extract face here as region of interest, and the computer can do many things. For example, we can measure distance between eyes here. So it will be one parameter alpha 1. We can sometimes measure the distance from here to the tip of the nose, and it will be alpha 2. We can measure this distance. We can measure also this distance. We can measure this one, and so on. Okay, there are many methods, you know, to achieve measurement. So from these parameters we can extract signatures. And once we have the signature, we can use it for the estimation, and your computer maybe will estimate for it. So always you have to understand it's like a competition between your computer and human being applications. So if your estimation is close to what persons can estimate, I would like to say it's good. If it's close to the reality, it's better. Okay? Always you have to think like this. Competition between your computer and the human beings, and you have something which is the reality. Okay? So this one, quickly.
4.5.
45,
40.
40, 45. Yeah. What? Who said 20? 30? Okay. Last? 35. Okay, let's see. So, human, okay, the average is around 30, I would like to say 35. No? 38. Okay? And your computer will do the same, will extract a region of interest, measure some information here, and extract the signature, and we compare it to this one. Okay? I don't know if it was the last one. Yeah, of course, for when you use a computer, of course, you can use as a sensor a camera. But maybe we can use other sensors. So, and this is what I was talking about. You know, the phase of training. Sometimes we can use this word. You can find this term, artificial intelligence. Artificial intelligence, where you need always two phases. You know, the training phase. You know, you can train your system with different phases here. And this is the test phase to estimate the age of someone, for example. So we have been talking about this because here in the training, you know, if I try to look at this block, what I will find the pre-processing, I will find feature extraction, I will find the database, and all this is integrated here. Yeah, this just the applications. We can imagine an application, you know, cigarette machine, you know, restricted only for adults. And we can imagine that we need to use age estimation, and depending on the age, we can grant the access to this kind of machines to some persons. So here we extract features, and we can notice the features that we extracted. Just maybe we can make a zoom here. I don't know if we can zoom. You can notice we extracted features from the eyes to have the shape of the eyes, nose, and also the shape of the face. And based on these features, we can estimate the age using some specific algorithms. Maybe here, if you have in some cases restriction to alcohol machines for adults, or I don't know, here we can use this kind of applications, you know, to get these restrictions. Yeah, here it's a kind of a smart TV. We worked on it a few years ago. It was in in 2012. We worked in a smart TV, and the idea is that, you know, we are used very often to watch TV. So the information, you know, we watch TV, it's, you know, in this direction. But maybe we are not used that the TV watch the persons. So it was the objective of the project, is that we used here a camera in the TV, and this camera detected all the different faces, okay, When we detect the faces, we estimate the age of each person, 42, 35, and I don't know, 3 years old. Okay, we detect the faces, we estimate ages, and based on the ages, we can decide if some programs are not suitable for kids. So automatically we filter, the list of programs, including in the same, for example, one movie. If something is not appropriate for kids, automatically some sequences are filtered. Why? Because the TV detects the person's watching this program. I have even one video. It was I made the video. I don't know if it was expression. I have one video. No, it's not here. I have normally one video where it was for the smart TV we developed. Anyway, maybe next time I can include it just to show you how it works. And you have also, you know, as we said, some estimations, some applications about what we saw. It was age estimation. In some cases, you can be interested not on age estimation, but in what we call model estimation. Do you know what's a model? What is a model? Because in some cases, you know, you look at this face and you see this person is 4 years old, this person is 30 years old, and this one is 75 years old. We call this an estimation. We have an input and output. We estimate. Model is something different. The model, if you have a model, you can predict the age of a person. Okay, you can predict the age of the person. Because if I give you, you know, let's show you one example where we can use a model. I have this person. When I say estimation, just I look at the person and I say it's 4 years old. Okay? I have 3 persons here. Okay? 4, 34 and 75. Okay, this is the estimation. When we say we would like to work on a model, it means if I apply my model on my data, you know, I will do it like this. This is the input, my image, and this is my model. Model is mathematical equations, and the output may be this image. Okay, so I can call it now an Asian model that we can use to predict, for example, the face of someone. Okay, to predict the face of someone. So the input is 4 years old, and I say, okay, I would like to see the face of this person at 34 years old. In such a case, you have to say, I have to use a model, a mathematical model, to modify the data here and to transform them to something different. Okay? So, a mathematical model is very important, and I think we need to discuss about modeling probably maybe next time, at least to make the difference between when we say modeling in general. Okay? Today we have to finish here at 10:30 as it was in the schedule. But next time I try to discuss much more about the model and models and mathematical models. Mathematical models. You have to understand this question very well. Okay? So I don't want to give you a lot of information now, but next time we try to talk about modeling and models, mathematical models, and why we have to use models, and in which application we can use model. And even you will notice that very often in different applications you have to deal with models, because model means reference, and for us as human, always we need a reference. If we don't have a reference, we are lost. Always we compare to a reference to make what we call an objective comparison. Okay? So modeling in image processing, in mechanics, in any field, it's very important. So you have to understand how to deal with models and mathematical models, and even how to estimate some parameters of the models next time. Okay? Do you have questions? I didn't answer. I'm yet to receive my emails to you. I don't understand. What do you mean? Okay, send me emails. Okay. Questions? No? So, Utara, what is not clear for you? No question. Okay, okay. You have no question. Okay. So think about projects. Have you? We discussed last Friday about projects. I received some emails from some of your classmates there's someone I think online who wants to work on face recognition for identification and verification, and he's an online student, and he can join the team working on face analysis. So probably I will forward, maybe, yes. Is he here, the one who sent me an email, who says that he wants to work on face analysis for identification and verification? I don't know if he's online now or not. So there is a team. We discussed this last Friday. One team will work on face recognition for attendance, to analyze the attendance. So students who are interested in this project, they can maybe join the previous one, or maybe they can create another team. Okay, because normally you don't have to be more than 3 students in for one project. Yes, Sayed. Yeah, I think you are the person who said, yeah, you want to work on identification. So as I said, there is a team they will be working basically on identification and verification. So you can discuss with them, and based on this you can see if you work with this team, or maybe if you need to work in another team. So what we have to do, we have to create a list of projects in which members of each team should be identified. Okay? So we try to do it online. Good. So thank you very much, and don't waste time. Work on your projects. Okay? Bye.